So when you've determined how many sig figs you have, let's say in a measurement, oftentimes those measurements need to be used in calculations, okay? And so you have a particular precision, let's say, that you used a very special scale that was very precise and it gave you a lot of significant figures. You want to make sure that that precision kind of carries through all the calculations you might do with that measurement. And so it's important to know how to use sig figs in chemistry problems. So the rules are when adding and subtracting measurements, you round the answer so that it has the same precision as the least precise measurement, okay? For example, the length of a knife, let's say, is 25.46 centimeters. The handle measured to be 7.8 centimeters. What is the length of the blade? Now, there's something interesting here. As a chemist, I'm looking at these numbers. You probably don't think they're strange, but I do. Why is there the length of a knife shown here to be precise to the hundredths place, and here it's only precise to the tenths place? So one of two things happened here. The length of the whole knife was measured with a ruler, okay, that you could get a hundredths of a centimeter out, okay? And then the handle was measured with a different ruler, okay? That was less precise. More likely what happened is the same person used the same ruler but just got lazy and found the hundredths place to be exactly 0 and just didn't bother writing it down. But because of that, they have now lost the precision that was in the hundredths place. And we don't know. I don't know. I can't tell what happened. Was the whole length of the knife measured with a more precise ruler than just the handle? And so as chemists, we have to be able to use these numbers in the right way. So basically, obviously, to find the length of the blade part of it, you just subtract the length of the handle from the length of the entire knife. And this is what your calculator is going to spit out at you. Unfortunately, this is wrong because I do not have precision to the hundredths place here, and so I can't report the hundredths place. Okay, this is a wild card. I don't know. Was it a 0? It could have been, but we don't know. Okay, and so I can only report my answer to the least precise place, which is the tenths place when I'm adding and subtracting. So I have to round this number. Okay, so I have to round it to the tenths place, and so I have to say that the length of the blade, according to the measurements that I've been given, is 17.7 centimeters. Okay? Now, when you are multiplying and dividing, it's a little bit different. You round the answer so that it has the same number of sig figs as the measurement with the fewest sig figs. Okay. So a box measures 1.05 meters by 2.1 meters by 5 meters. What's the volume of the box? Now, again, as a chemist, I'm looking at this and thinking, did somebody really take a box and measure it with one ruler that was precise to the hundredth of a meter, and one ruler that was precise to the tenth of a meter, and another ruler that just gave you meters? Not likely. What probably happened is someone got lazy, and this was actually a 0 and didn't bother to write it down. And then this was probably 5.00 meters, and they didn't bother to write that down. They got lazy. But the reality is I don't know for sure. So I have to use the least precise measurement. Okay? So to find the volume, obviously, we just multiply height, width, and depth together to get the volume. And this is what my calculator is going to spit out at me. Now, with significant figures, your calculator is not smart enough to figure out what the significant figures are supposed to be. But being a person and being a chemist and more analytical, I get to decide where things need to be rounded. Now, if I look at this, I have 3 significant figures in this number, 2 significant figures in this number, and only 1 here. And because my rules are when I multiply and divide, I need to go to use the number with the fewest significant figures. I can only have 1 significant figure in my answer. So this has 1 significant figure. So by being lazy, probably, and not saying 5.00, I now have dropped my precision down to 1 significant figure, and my answer is going to suffer for that. Okay? So it can only round, this answer can only have 1 sig fig. I have to round it to the nearest 10. So this is the only thing I can report. This has one significant figure. This 1 here is significant. This 0 is not because there's no decimal place here. And this is what I have to report for my answer. So you can see where taking measurements, precise measurements, and writing down all of the significant figures, even if you think you don't need them, is very important, especially when it comes to using significant figures in chemistry calculations.